Everyone, welcome back. Hope you're enjoying your second snow day in a row and staying warm and inside. I wanted to do something a little different today so that we all can participate at home. We can watch this video whenever we get on Canvas today. The problem with Zoom is if you miss a Zoom call, well, then you miss everything we did. And then also, I need you to pause this video when I ask you to pause it. There's a lot of examples we're going to talk about and do that I want you to put in your math notebook. So whenever I say pause, go ahead and hit pause on the video so that you can look at the screen and do the problems on your own, and then keep going with the video. So you're going to kind of do it along with me as I go through these slides. All the things we're talking about today come from our Unit 3.3. Unit 3.3 is all about positive and negative numbers, integers, and rational numbers. So let's talk about some of our goals and some of the things that I want to do today. The first thing is looking at a number line and making sure we can compare numbers using that number line. It's going to be a big part of this unit. Second thing is I want to be able to talk more about what a rational number is. And we're going to see more of those rational numbers, those positive and negative numbers, whether they're whole numbers or fractions or decimals. We'll see that today. And then the last one is to use inequalities to compare positive and negative numbers. And you've done inequalities before. Maybe you forgot what they were called. So let's jump right in. This first slide here, you can actually pause and use it kind of as a warm-up. There's 3 questions here I want you to look at. So go ahead and hit pause right now and do these questions in your math notebook. And after you've got those in your math notebook, you can see where the theme of today is positive and negative numbers, which actually has a lot to do with temperature in this example here. And it really matches kind of what's going on in Liberty today. I think the wind chill in Liberty was like negative something, -3 or 4. So pretty cold here. But the big idea is this. When you look at that 3-question warm-up you just did, I want you to think about this number line as you think about, okay, 0 is a temperature. If you go bigger, go greater, it gets warmer, and we know that. We like nice 70 degrees summer days. We don't want it to get super cold, but if it does go super cold, it gets in the negatives, those negative numbers actually start to get bigger. They're not really bigger though, they're just more negative. Because if you think about a number line, we always have this theme of going to the left is less, or less than, going to the right is more, greater than. That needs to be kind of ingrained right now with what we think about positive and negative numbers, because we're going to see this come up again. So on this next example, I'm going to do this one kind of together, but I want to give you a moment to pause and make a quick guess on number 1, 2, and 3. But let me read the question first before you pause. Another temperature scale frequently used in science is the Kelvin scale. In this scale, 0 is the lowest possible temperature of anything in the universe, and it is negative 273.15 degrees in the Celsius scale. Each 1 Kelvin is the same as 1 degree Celsius, so 10 Kelvin is the same as negative 263.15. So I don't know if you've heard of Kelvin before, but it's another way of measuring temperature. Go ahead and make a guess on number 1, 2, and 3 in your math notebook, and go ahead and hit pause now. All right, now that I have had a chance to look at this, it says water boils at 100 degrees Celsius. What is the temperature in Kelvin? Well, we know Kelvin always starts at 0. Starts at 0, it doesn't go below 0, and that is negative 273 Celsius. So to get to 100 degrees Celsius, we have to add negative 273 to get to 0, and then another 100 on top. So this, number 1, this answer would be 373.15 degrees Kelvin. 373, because we should add 100 to this, but it's got to be positive. A great tip, if that's kind of confusing, is to make a double number line. We've seen double number lines before. Make a Kelvin number line, make a Celsius number line, and the only number that needs to line up is the 0 Kelvin and the negative 273.15 Celsius. And then you should see where you get the answer for number 1. It says ammonia boils at negative 35.5 degrees Celsius. What is that boiling point in Kelvin? Okay, so again, we know 0 is this number. We need to get from negative 273 to negative 35. And so we need to do some adding to get there. And it's going to be positive because Kelvin's always positive. Kelvin doesn't go negative. And so if I do some quick math here, it's going to be 230 238, about 238 point something. I'm doing this in my head, so I have my computer out, not a pencil and paper. You can do the math. So if you take 35.5, subtract that from 273.15, and that's kind of why we did our decimal unit just before this, you're going to get, I think, 238, and doing this again, 65 maybe, 65.65. Someone check me on that. All right, last one. Explain why only positive numbers and 0 are needed to record temperature in Kelvin. So you notice both those numbers on number 1 and 2 are positive, and the reason is it starts at 0. It doesn't go negative. That's the lowest possible temperature. That's what it told us in the problem up there. And so Kelvin is only positive. So it's a way of measuring that temperature, that heat, using only positive numbers. So here's the big kind of four problems for today. You notice number 1, it's got a big number line. I want you to put that number line in your notebook and just plot those points. Number 2 then has these inequality symbols. This is what an inequality is. I think you've seen these before. It's just greater than or less than. Which of these numbers are greater than or less than? And then 3 and 4 starts to get a little interesting. That's when you see fractions, positive and negative fractions. And that might be a little confusing as you do these in your notebook, but I want you to think about a number line. Think about where these would go on a number line and how you could just plot them to show, okay, if it's over here, it's less than. If it's to the right, it's greater than. You can always compare numbers that way. So go ahead and hit pause on this and get number 1, 2, 3, and 4 in your math notebook. Now that you've completed these all 4 should be in your notebook. I'm going to check these when I see you next in class. These are the 4 we're going to go over. So make sure you have these ready to go so we can look at them together when I see you next. 1, 2, 3, and 4. Go ahead and circle those in your notebook. Go ahead and circle them, put a star by them so that we can easily find them in class. And here's our last slide that we want to talk about today. We're gonna finish up here by looking at this number line. Once again, you see that there's fractions here. It's just a normal number line, -2, -1, 0, 1, 2. But they've got fractions in there, some positive, some negative. And you can see how, as we go to the left, we get more negative, but the fraction kind of gets bigger, but it's a negative fraction. Over here, we get more positive, and you can see normally we get bigger. These fractions get bigger. So I got some true-false for you. -5/4, is that greater than -3/2? -5/4 is over here. -3/2 is over there. Yeah, it's greater because it's more to the right. This one, -3/2 is less than -3/4. Is this less than this? Yes, it's to the left of it. So it is less than. This is greater than that. This is larger than this. -3/4 is larger than -3/2. Number line really helps us see that. 5/4 is farther from 0 than -3/2. Oh, that's an interesting one. So 5/4 is over here. -3/2 is over here. Which one is further from 0? Well, it looks like -3/2 is further from 0. And that makes sense because that's, as a decimal, that's 1.5, -1.5. Over here, this is positive 1.25. Last one is -3/2 is farther from 0 than -3/4. Okay, this one will be easy. -3/2, -3/4. Which one's further from 0? Well, -3/2 is, yes. That's further from 0. So hopefully all of this is making sense with the number line. I know today virtual is not the best way to introduce something new, but I'm hoping this video gives you a chance to pause things and kind of think about what's on the screen. Put these in your math notebook. Make sure you bring these to class, and if you have any questions on these, feel free to reach out to me today. Send me an email. We can set up a Zoom if we need to, but send me your questions if you're confused, and I'd be happy to answer them. Have a great day, everyone. We will see you guys soon. Stay warm, and we'll hopefully get back in class here tomorrow.